Okay, question 8 in the June 23 paper 1. Now, this question, when my students tackled this, I think they all looked at it and got scared. There were quite a few students who just kind of looked at it and were just like, nope. But I would strongly advise you not to look at questions and be scared of them like that, because this one is not that difficult when you actually look at it. The two main things you need to know are arc length and your sector area. And if you remember from GCSE, its arc length is 2 pi r, which is the circumference of the circle, and you want to multiply that by the fraction of the circle that you've got, so whatever angle it is. And in radian measure, instead of 360, we should know by now that it's 2 pi. And when you look at that, that simplifies out into theta r. Similarly, with area of a circle, exactly the same thing. Pi r squared is what we do for a circle. If we want a sector, we want some angle out of 2 pi times that. Pi cancels out, and what we're left with is theta r squared over 2. So those are the two major formulae that we'll be using for this question. And while it looks difficult, I strongly advise you, once you see, it's not too bad as well, especially seeing as they've given you a lot of the answers. So first of all, show that OC is 12 meters. So OC from there to there. And what you're going to be looking at is that sector there. So for part A, I'm just going to make a quick copy of that sector, where that's 2.3 radians. We know the arc length is 27.6, and what we're trying to work out there in effect is the radius of this sector. And using our arc length formula, we can say that 27.6 is equal to the angle, in this case 2.3 radians times r. So r will be 27.6 divided by 2.3, which gives us 12 meters QED. That which was to be proved. Now, part B, so again, they've given you the answer, so a lot of this is working backwards, and in these type of questions, if they show that and they give you an answer, you can play around with it until you get to the right answer as well. So never be too afraid of that. Now, for part B, it says show that the size of angle AOB, so AOB, is 0.421 radians. So that's what I'm looking for in this case. I'm going to just get rid of that, I'll be putting that in shortly. So now if you look at the situation you've got here, that's a straight line. These two triangles have been told that they're congruent, so there's a lot of symmetry going on here. So you've got a straight line, you've got an angle of 2.3 radians, and then this angle here must be the same as that due to the symmetry of the shape. And we know that angles on a straight line are 180 degrees or pi radians. So therefore, 2x plus 2.3 equals pi. So 2x will be pi minus 2.3, and x will be pi minus 2.3 divided by 2, which again, if you work that out, you'll get 0.421 radians. And again, QED to show that which was to be proved. Now, the last part, so worth 6 marks here, says given that the total length of the front of the stage B, C, D, E, F, so that there is 35 meters, I need to find the total area of the stage, giving the answer to the nearest square meter. So first of all, let's look at what they've told us there. We know that this length here, the arc length, is 27.6, and what we need to work out is what are these lengths here. And we know that all three add together to make 35. Again, using the symmetry of the shape, we can see that these two will be the same. So therefore, 2x plus 27.6 is equal to 35. So 2x will be equal to 7.4. And then if you half that, you get x is 3.7. So now I know that's 3.7. That's 3.7. I also know that from here that was 0.421. And again, because they've given you these bits here, so we knew that OC was 12. We know what the angles are in there. We've now got enough information to work out the area of that entire shape. So we're going to split it up into two main shapes, the area of the sector and the area of the triangle. So let's start with our triangle. We know this angle here is 0.421. And that triangle has a total length of those two combined. So that will be 15.7. And then looking at this bit here, again, using the symmetry there, you can see that that's going to be 7.5 because it's half of 15. And from there, we know side angle side. So therefore, we can use half AB sine C to work out the area. So the area will be half times 15.7 times 7.5, half AB times sine 0.421. And if we work that out, that gives us 24.0606 ... That's the first stage done there. And then the next thing we need to work out is the area of the sector. So looking at that sector, and again, I like to just have a little sketch of it as I'm doing it, just to make sure that I'm putting the right information in there. So that's 2.3 radius. We know, 2.3 radians for the angle. It's got a radius of 12. So looking at that, going back to our area formula there, the area will be 2.3 times 12 squared over 2, which works out to 165.6. And then your last step then is to combine the two. So if I want the area of all of them, I need two triangles and this sector. So therefore the total area will be 2 times 24.0606. And then I need to add on 165.6. And that works out to be a total of 213.7212 ... which again simplifies down to, well, we need to give it to the nearest square meter. So to the nearest square meter, that will be 214 meters squared. So again, this question, it looks a lot harder than it is. They give you a lot of information. So even if you didn't know how to do certain parts, even if you didn't know how to do A and B, because they've told you what OC is, they've told you what the angle AOB is, you can still work out, you can still get these 6 marks even if you didn't know how to do the previous parts. So I'd strongly recommend, when you look at these type of questions, don't be afraid of them. Head straight in and you will start to work them out. Similarly with these two formulae, you don't even need to memorize them. As long as you remember from GCSE, or you understand how to work out your arc length and your area in degrees, all you need to do is change it into radians. So instead of 360, you write 2 pi, and you'll find that they simplify out quite nicely.